Hey everyone, I recently joined a happy hour call for Playwright where they announced a new clock API. This announcement was really exciting, but I also felt it led some people into confusion. So I've decided to record a video to try to explore what the clock API actually does and how you can use it in your own tests. So let's get into it. I have created a couple of examples that we'll go through and I'll show you how they work. So this first example is current time. So this is an application that shows my current time as the time of this recording. Now back in VS Code I have a test that checks this page and makes sure that it runs correctly. I'm sharing this code in the comments, so if you want to dive in, feel free to take a look at it. Basically what I'll do, I'll open the page, make sure that the test is in correct format, and then I'll do the following. I'll check the initial time, then wait for 2 seconds, I check the updated time, and make sure that the time difference between initial and updated time is equal to 2. Basically, I'm trying to determine that the time actually works and moves forward as it should. I'm now going to run this test using Replay Browser. And as the test finishes, I can go ahead and take a look. As I can see, the test has passed. And if I take a look inside the code, I can see how the time iterated. So we got 4:37:27, then we jump to 28, and then we'll jump to 29. As we look into this code and see this current time changing, we can examine a little bit more about what the code does. Here's a use effect hook that will update our time. And it will do that in 1 second intervals. It is using the setInterval function that uses the browser's clock to update the time every second. It will call the updateTime function every second. This is one of the JavaScript functions that deals with time. And a new Playwright's clock API can wrap these functions and essentially give them their own value. In essence, it feels like you're rewriting what the function does. So setInterval is not going to be doing what it is doing by default, but it is going to do whatever Playwright tells it to do. So what does this mean for our tests? In our test, we are waiting for 2 seconds so that the real world time will move and actually give us the updated time. But instead, we can do sort of time traveling. So let's take a look. At the very top of my test, I'm going to add page clock install and pass this function a time, which is going to equal to a new date. And then, instead of the page wait for timeout, I'm going to say page clock fast forward and pass 2 seconds. What's going to happen now is quite interesting. I'm going to run my test again. And open my replay. And I can see that my test is pretty much the same. But instead of waiting for 2 seconds, I have fast forwarded the time, which can be seen if we compare these two test runs. So this one is 1 second long, and this one takes 3 seconds. And this fast forwarding the time can be really useful in some of your tests. Let me show you another example. This is a compliments app. If you click this button, it will give you a compliment. As you can see, that compliment appears for about 4 seconds and then it disappears. I again have a very simple test that will open the page, find the button, click on it, and then make sure that the compliment appears, but also that it disappears after 4 seconds. Let's now run this test. Open it, and we can see that the compliment appears and then disappears. And our test will pass. Now again, if we take a look into the code, we see that we are using the setTimeout function. This logic will take care of the compliment appearing and then disappearing. So if we click on this button, a handle click function is called. This will take a random complement, it will pass it on to the state, and then make sure that the complement element appears, which is handled by this setShowComplement. It will set it to true. But in here, we have a timeout setup, so that after 4 seconds, which is handled by setTimeout function, the setComplement function will be called with a false, which will make the complement disappear. If the number instead of 4,000 was 60,000, so 1 minute, then the complement will appear for a whole minute. This would make the test really slow, and essentially it would not do anything for a whole minute. And that's why the clock API is incredibly useful. We can once again use the page clock install to initiate the initial date, and then instead of waiting for 4 seconds, we'll fast forward 4 seconds in time. We'll pass on 4 seconds, run the test, and this time we can see that the whole test takes only 1 second, and if we play it back, we don't even see the complement appear. But in fact it does appear. If we take a look at the DevTools and jump into the complement button, we can jump to a moment where that complement has appeared. It is good to keep in mind that this clock API is able to handle functions that run in the front-end code. It is not possible to change a server code. Let me show you an example. In my final example, we can take a look at the current time on ISS. If we take a look into the console, we'll see that in Network Panel, we're calling the API every second to update the time in the server. As a response, we'll get all the data about current time on the ISS, which is then handled inside our application. If we take a look at the code of our application, we'll see that this fetch API call is made, and then a response is fed to the application. So in this code, we are not relying on the front end to get the current time, but we're actually fetching it from server. In this case, we're not really able to use the clock API, because that will only handle the time in the front-end code. Whatever comes from the server is out of our control. For that, you can check out the root API, which enables you to mock the response from the server. Anyway, that's been it. Hope you enjoyed the video. I'll see you next time. Happy testing.